Hello everyone, it's Danny and I'm going to talk to you about the invasive Argentine ant and its effect on the native ant communities and how the invasion can be controlled a little bit by small human actions. So, for those of you who don't know, the Argentine ant is an invader spread worldwide and it's originally from this blue area in South America and is spreading in natural habitats in all these orange areas you can see in the map, and indoors in all the yellow areas. It's mostly northern countries and Oceania. So I'm going to talk to you about the invasion in the 𝘓𝘮𝘮 National Park. This is located in south Spain, in this red mark you can see on the map. And I'm going to introduce you how the invasion started here. In the 70s, the ant started invading the park through the restoration on some of the buildings. So the first invaded place was the Palacio Doñana. In the 80s, for first time a cork oak was found invaded. In the 90s, further cork oaks were also invaded, and a pine forest here in the map, in the lower part of the map. And in 2009, a new area in the north was also invaded in some of the cork oaks you can find there. So the invasion of the Argentine ant is very connected with buildings. So the closer you are to the human construction, the more Argentine ant you will find if it's an invaded area. So you can see here in the graph, and here in this representation I try to do, the closer you are, the more Argentine ant you find, and the farther you go, the more native species you can find. And this is why, because this Argentine ant is present a very low tolerance to the thermophily. I mean, it's not thermophilic at all, it cannot resist high temperatures. So use these constructions or natural habitats as cork oaks as a protection against the heat. So what are the effects that the Argentine ant have? So have effects on different kind of fauna like birds. It was found that the trees that were invaded by the Argentine ant present in the nest chicks with the lower physical performance in comparison with the non-invaded nest. As you can see here, they have lower mass and smaller wings, and they also present indicators of high stress as lower amount of triglycerides, and a lower amount of total proteins. And you can see in the photo here that we have a nest with the different chicks, and in one of the chicks you can see an Argentine ant biting them, but probably there were many more. And also the Argentine ant have a strong effect on the amphibians because they have a chemical compound called 𝘓𝘮𝘮𝘮𝘮 that cause skin necrosis on the amphibians, and at some doses can even paralyze them. And for sure, they die and the ants can eat them. So I'm going to introduce you the sampling we performed in our study of monitoring of the Argentine ant in two different places. One of the human construction was a fence made of concrete, and the other one was a building. The sampling was done at 4 different distances in 2 different directions from the building, at 0 meters, 10, 30, and 50 meters. And in each of these sampling spots, there were 7 pitfall traps and 2 groups of baits. The baits consist in honey, biscuits, cheese, and sausage. And the baits were used to check the replacement of a species, the interaction between species, so which species can outcompete which other species. And the pitfall traps were used to study the taxonomical diversity at each of these different distances. So here we have the results of the baits. We can see the Argentine ant here and here, so it's present at the closest distances to the building. This is the 0 to 5 meter distance, 10 to 15 meters, and 20 meter distance from 8 AM to 12 in the night. So we can see that at the beginning of the day and at the end of the day, the Argentine ant is when it's more active. But during the day, there is one species that is able to survive to the invasion. That is the native species 𝘓𝘂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂 when the Argentine ant cannot. And also when they are not active, they close the nest. So the Argentine ant, when they are active, they cannot find them and they can survive. So, but the farther we go in distance to the building, we see that the Argentine ant became less common in the beds, other species appeared, and at some point when there is no Argentine ant at all, like plus 20 meters, we can find other dominant species that have an overlapping on time on the niche, on the time niche with the Argentine ant, and is when they appear, when they don't have the competence of the Argentine ant. Otherwise, they would be outcompeted and they wouldn't be there. Here we have seen this photo, like a bunch of Argentine ants feeding on one of the beds when they are monopolizing it. Well, and yeah, I forgot about this. This is for showing how the temperature increase and decrease. So during the hottest moment of the day is when these thermophilic ants are active. And this is why they can survive with the Argentine ant. So here we have the results of the pitfall tracks. So the composition of the ant community. We have the two study places. We have, this is 𝘓𝘪𝘯𝘦𝘮𝘮, this is the place where we have the concrete fence, and this is the building. And we see that in 𝘓𝘪𝘯𝘦 something happened, because at the beginning, from 2001 to 2005, there is a pretty high density of ants, Argentine ant, but then it drastically dropped. And this is because in 2005, the fence made of concrete was replaced by a fence made of wood. And this is not a suitable habitat for the Argentine ant anymore. So the Argentine ant decreased a lot in numbers, and other species were able to colonize the area, or increasing in population number, as the thermophilic 𝘂𝒂𝒂𝒊𝒔, the one we talked about before. But nothing happened in another place, in which I just represent here the moment in which the fence was removed in the first place, but here it was an unmodified habitat. So there were no changes, it's kind of a control place. So to check that maybe this decreasing was because of environmental factors, and not because of the fence, but actually not, because if not here, the decrease would also happen. And we can see that at further distances, even the Argentine ant completely disappeared, just by replacing the fence made of concrete by a fence made of wood, which is not a proper place for the Argentine ant anymore. Here we can say the same in a more simple way, just comparing the Argentine ant versus the thermophilic species. We see that in the moment when the fence is replaced, just the native increase a lot and the Argentine ant drop in numbers. And in the control place, nothing happened. And just to finish, I want to show you like a community, whole ant community picture. In this NMDS, in the restore habitat, we can see how the first NMDS show differences between close versus far communities from the building. Here in the second place we can see the same, close versus far, and we can see clear differences. And the difference is that in the restore habitat we can see in the second component of the NMDS a difference between before and after the restoration. But this difference before and after cannot be found in the second place because nothing changed. So I would like to give you 3 take-home messages of this talk, and is that the thermophily can be the key to be resistant to the invasion of the Argentine ant in this kind of habitats, that the presence of Argentine ant reshaped completely the whole ant community, and that the small modifications can reduce the negative effect of the invasion. So thank you for your attention. I hope you liked it, and well, I'm open to further questions.